Here we are discussing about sample and hold circuit performance parameters. First parameter is acquisition time. Suppose we have a input signal and it was in hold condition H, and now we have given the command to sample. So it is the time required for the holding capacitor to reach to the specified value of input. So this time that is required is called acquisition time. So basically, when we give the command for to the switch to acquire the signal, and we say okay, let's sample it, we give the command of sampling, then capacitor will start charging. So it will take certain time to reach to the desired required value. This time is called acquisition time. The second performance parameter is aperture time. So basically it is the time elapsed between the command to hold and actual opening of the switch. So basically it is the time we say okay, now hold, and time it actually required to actually open or needed to open the switch. So there is a delay, which is called aperture time. So by that time the output voltage still keep on tracking input voltage, and this time is usually because of the propagation delay, and it is denoted by TAP. So third performance parameter is aperture uncertainty, also known as jitter. It is the uncertainty in the aperture time, and this comes from the noise that is superimposed on the hold command, and it shows that sample to sample variation. Suppose we have an input signal and we have given the command to hold, and there could be a variation. It can occur at t equal to t1 or t equal to t2 or t equal to t3, which lead to us to the uncertainty in the aperture time. This is called as jitter. The fourth one is feed through. It is due to the AC coupling. What's happened? What's happened in hold mode, because of the stray capacitance across the switch, there is a small amount of AC coupling between output and input. This AC coupling causes the output to vary with the input voltage. Suppose what happens is that we have input voltage, okay, then we have a, depending upon whether we are sampling or holding, the output voltage. Suppose we are at hold voltage, so there should not be any change in this voltage, but because of this feed through, the little change that is occur in the input voltage, it also lead to the little change in the output voltage, because of this coupling, AC coupling. The fifth one is sample to hold offset. This is due to the parasitic switching capacitance at the time of switching from sample to hold. This occurs because there is an unwanted transfer of charge between switch drive and the holding capacitor. This causes change in the value of CH, and this is known as sample to hold offset. And the sixth performance parameter is hold mode settling time. What happens is that after application of the hold command, it takes certain amount of time for the output voltage to settle within a specified error band. It could be 1%, 0.1%, and 0.01%, depending upon us what we have specified. So there is a certain time it requires, and which is known as hold mode settling time. Now suppose we have an input signal and we have given its command, let's say hold and sample and the hold. When we give it a sample command, start capacitor will start charging towards its input value, and once it start following the input value, then we say hold. So after the hold, it start to settle within an error band of defined value, which is called hold mode settling time. So basically, after the application of command, it takes certain amount of time for the V output to settle within a specified error band, which is called hold time. The fourth and the seventh one is the drop. What is there? This is basically a constant drift of the output voltage due to the charge leakage from the hold capacitor through a switch or output buffer. What's happened is that when we say it's holding, but there will be some leakage that is happening, so nothing is perfect. So because of which there is a little small amount of voltage drop